story. So thank you, Dan, for inviting me, and thank you all for welcoming me here. You've been here for what, 3, 4, 5 days? Celebrating California native plants, yay! I'm a born-again native plant person. I bought 5 acres at the summit of the Santa Cruz Mountains above Los Gatos in 1993, and when I moved in, it was just French broom or Scotch broom. I still debate, is it French broom or Scotch broom? Thistle, star thistle. It was a 6-foot-tall broom. It was just a nightmare, and I spent years eradicating it. Yeah, plant by plant. Some of those broom plants are like that big. I got one of those pullers. What was amazing is, after it was all cleared out, the native plants started coming back. And suddenly there was the globe lily and 2-eyed violets, and then one day I was like, oh my God, what's that? And it was a striped coral root orchid? Yeah, so I feel very lucky. All right. So I'm going to talk about new tools for conservation, and you all have been using many tools for many years. There's a lot of wonderful things out there. We have a few that could be good arrows in your quiver, and I'm going to talk about them today. Dan did ask me to tell you the story of how it all started. So, it starts with Google Earth, which launched in June 2005. How many of you have used Google Earth? Okay, no question. And so, more than 1 billion people have downloaded Google Earth, and for many people what they do is they fly to their home, and then they're like, well, what do I do now? Well, what we're looking at here is a previously unknown coral reef off the coast of Western Australia that was actually discovered in Google Earth. So, yeah, people are using Google Earth to make virtual discoveries about the natural world. The man who did it worked for an agency in Western Australia, and he said, I felt like a bloody desktop Darwin. And it was not just amusing, but it actually was relevant because it's a very remote area. There are no roads, and the area was about to be subjected to oil and gas exploration as a prelude to mining, and the fact that there's this rare fringing coral reef now discovered made a difference. Yes, we're like on the voyage of the Beagle of Discovery. So now my story. Again, it's the summer of 2005. I open the mail one day and I get this notice. Now, many of you are map people. Maybe you can read this, but most normal people cannot read this map. So about 2,000 of us got it. Notice of intent to harvest timber. Non-industrial management plan area, according to the legend, is marked with black lines. Well, that's very helpful. I understand now. So most people did not understand this public notice, which was, as Dan said, probably the point. And so many people threw it out. But a number of us were concerned about what this might mean. And so I was at that point then a Google engineer and pretty comfortable with Google Earth. I took a weekend, I studied the plan. I said, what will happen if I remap the elements of this plan in full 3D high-resolution satellite imagery? Will we have a better understanding of what's at stake and whether we should be worried or not? So I did that over the weekend. So this is that same place in Google Earth. And then I started to annotate, which is very easy to do. You don't need to be a programmer to bring in the information about the plan. As I mentioned, you can do 3D in Google Earth. And so I also, with the oblique angle, I also brought in a model of a helicopter with a tree, because the land was so steep they were going to be doing helicopter logging. They couldn't get the logs out by road. You could see how close it was to the daycare center, the nursery school, the elementary school. People in the community started getting involved and giving me data, like, for example, this photograph of a beaver right at the base of where the logging would happen. Charlie the beaver, he became our mascot. We called ourselves Neighbors Against Irresponsible Logging, or NAIL, and which worried the loggers. And then, but Charlie was our mascot because beavers are responsible loggers. They are not greedy, right? So this was at the time when Al Gore was going around doing his talk about an inconvenient truth, and I was like a mini-me Al Gore, going from public hearing to newspapers to Sierra Club meetings and community meetings. No one could understand the 400-page document and those maps, but in a few seconds they could understand what was at stake with Google Earth. And so it started getting noticed by the media that there's this new tool called Google Earth that is empowering public participation. Yeah, and so then one of my neighbors said she nearly fell off her chair. She, looking at the 3D visualization in Google Earth, she had a much better perspective of what was actually at stake. Green Eyes in the Sky, the Chronicle noticed it. The Wall Street Journal said activists start Googling, right? The Mercury News talked about technology building a bigger soapbox, which was kind of fun. And then it ended up, I think the next one is, it ended up getting put even on the CBS Evening News.
Well, tonight a battle is brewing in the South Bay over plans to log 1,000 acres of land. Tony Russomanno shows us exactly what's at stake.
We're taking a Google Earth virtual flyover along a 5-mile length of Los Gatos Creek between Lexington Reservoir and Lake Elsman in the Santa Cruz Mountains. The area in red, totaling 1,000 acres, is land that San Jose Water Company wants to log. The map was created by a software engineer who lives in the area, and it's being used to galvanize opposition to the company's plans.
So instead of having an abstract map, people can actually see their houses, see their schools, see where the logging zone is. And it changes an abstract concept to something that is quite striking.
That was the aha moment, that it takes something abstract, you get charts and graphs and words and so on, but when you can see it in full 3D, your community, what's at stake, it changes the game. And so, as Dan gave you a hint, we used Google Earth not only to show that the plan was a bad idea for water quality, for public safety, for it would increase fire danger, but we used Google Earth to prove, in fact, that the plan was illegal, and with that, we stopped the logging. Charlie and his family still live there. So that led to my starting what became Google Earth Outreach. Every Google engineer can spend 1 day a week. It's called the 20% Project, doing something you're passionate about. And so, actually, I don't know if Jack Dangermond was here, but I was inspired by the Esri Conservation Program, and I said, I'm going to start the Google Earth Environment Program, right? But GEEP didn't sound that good. And then Google Earth started helping people use it for human rights, for cultural preservation, disaster response. So then we broadened it to Google Earth Outreach. And if you go to earth.google.com/outreach, there's now a ton of resources there, that tutorials, case studies of how people all over the world, organizations, are using Google Earth, Google Maps to make the world a better place. These are just, there are thousands of wonderful things that are so inspiring. One that I wanted to just highlight, I know Dan did a cool project for CalFlora a few years ago. This is one that I just opened up this morning. It's called iNaturalist. So I talked about ground to the cloud. There's a lot you can do with satellite imagery, but you can't do everything with satellite imagery. People on the ground, people like you, citizen scientists and so on, or scientists on the ground, can collect valuable information. And so iNaturalist is a sort of crowdsourcing platform for anyone to be able to collect observations, upload them. If you know what they are, you say, and you can take a photograph. If you don't, experts can tell you what they are. So I just noticed people were uploading things like dirtwood termites. Anyway, this morning, you can see it's plants, animals, all sorts of different categories. So I went in to see what does the Bay Area look like, and for example, here's an observation. I can't read it from here because I don't have the screen in front of me, but it's a fun crowdsourcing tool for observations of plants. Another ground to the crowd story is Chief Amir Surui came to visit Google in 2007. That is his territory in the Brazilian Amazon, which was being illegally logged, and he was the first member of his tribe to go to university. And in the satellite imagery in Google Earth, he stumbled on Google Earth in an internet cafe, and of course he flew to his home, and what he could see, which he hadn't known, were places of illegal invasion of his land. And he said, this is a really powerful tool for us to use and for us to raise awareness with the outside world about what's happening to our territory. And the time has come to put down the bow and arrow and to pick up the laptop in order to defend our land. So he came to Google and he asked me to come down and bring a team of Googlers to train them on how to use our mapping technology. We did that, and as soon as Android devices came out, we went down and taught them how to use those for vigilance, for actually detecting and photographing, documenting the illegal invasion as it was happening. And it was funny because, you know, the authorities had been saying, oh, well, you didn't give us the right information, we didn't know. Well, with the devices, they're automatically time-stamped, date-stamped, GPS located, put on a Google map, video can go on YouTube. So now the, you know, Chief Amir can say, well, maybe you didn't know, but 1 billion people are looking at it right now. In YouTube and Google Maps. So he feels that it's really given them a lot more credibility with authorities. They're also using it for cultural mapping, for transmission of cultural information from elders to youth. And what's been really exciting is they've become the first indigenous-led project to be certified for forest carbon offsets, and they have now sold those to the largest Brazilian cosmetics company, which has completely transformed their ability to live now sustainably and not rely on handouts. So, in fact, tomorrow I'm getting on a plane to go back to meet with Amir. Chief Amir invited me to come back now because all the other tribes in the area are clamoring and want to do a similar project, and they want him to introduce them to Google. So we're going back. That's exciting to scale it up. So now, what's going on? Well, so, you know, that's Google Earth and Google Maps. As I said, you know, more than 1 billion people have downloaded Google Earth. More than 1 billion people use Google Maps every month. Are we done? No. And, you know, as you all know, the world is changing in ways that are observable from space. For example, more than 1 million acres of Amazon rainforest have been lost, even just annually at the time that we were down there. And so we were asked by some Brazilian scientists, geoscientists, to build a new technology. They said Google Earth and Google Maps are great for looking at satellite imagery, but we need to map and measure and monitor the changing surface of the planet. We're losing millions of acres of rainforest. A lot of it is illegal. It's happening in remote parts of the rainforest where there's not good law enforcement on the ground. However, there's daily satellite imagery, and we have the scientific ability to analyze that data and detect change, suspicious change from last week to this week. And we could therefore create a virtual monitoring system. However, the problem is it's terabytes or petabytes of data, billions of megabytes of data. And when they would try to run their analysis on a single computer, it would take weeks. So by the time they would get the result, it was too late. And he said, you know, you supposedly have a lot of computers at Google, and you have the satellite imagery. Can you let us do science on it? And so that led to our building what we call Google Earth Engine. Earth Engine because it's an analytical engine for the planet, an environmental engine of satellite data, all sorts of environmental data feeds. So we started with the fact that there's a treasure trove of publicly available satellite imagery. These are just the satellites that NASA manages. For example, the Landsat satellite has been, or mission has been systematically, continuously observing the planet for more than 40 years. There's millions of images that have been collected. The problem is that they come off the satellite and they go onto tapes in a vault in South Dakota. So the data is very secure. which is good, but it's not that accessible, right? So we worked with the US Geological Survey to liberate all that data, right? It took, I think, 4 years to get all that Landsat archive, 40 years of data off tape and onto computers running in Google data centers, running Google Earth Engine, so that it could now, we could actually do what's called data mining. We could actually mine that archive for change and for what's happening. So when you have all the data, you can do interesting things. Like, for example, this is a typical satellite image, a lot of clouds. But the Landsat satellite collects 20 images a year over every place on Earth. And so the clouds move around. So if you can sift through those pixels, you can create an annual composite image and typically find at least one good cloud-free instance of every pixel. So we did that using Google Earth Engine, and we turned something like which is this is Borneo, into cloud-free Borneo. This is the Isle of Mull in England. We can make it look like this. It never actually looks like that. Then we said, well, can we do this at continent scale? Well, we have a lot of computers, so yes, this is what South America actually used to look like in Google Earth and Google Maps. But now if you open them up and look at the satellite base map, it looks like that. And then we said, well, let's just do the whole world. And that was a fair amount of data, but again, we have a lot of computers, and we created the first global 15-meter resolution cloud-free image of the entire planet. So you can zoom in very far in that image, and it's quite beautiful now, and it's helped a lot of conservation efforts. For example, Ecuador and Colombia used to be completely covered by clouds. Now they have this cloud-free imagery. So then we said, okay, so that's one moment in time, but we have 40 years of data. Can we do something to help the world understand how the surface of the planet is changing? And in fact, so we built something we call Earth time-lapse. Starting in 1984, because that's when the data became most complete and good. It's 3 decades of change. We have this for the whole planet. And you can see phenomena like glaciers receding, irrigation in the desert, the creation of the artificial Palm Islands off Dubai because they wanted more beachfront for tourism, deforestation in the Amazon, and here's Las Vegas, the fastest growing city in the United States. And what I find interesting is look at how Lake Mead is shrinking while Las Vegas is growing. Again, you can see something in seconds, right? But to produce that was not trivial. We launched this, by the way, in collaboration with Time magazine. They did fantastic reporting, science and environmental reporting on what you could see and understand for the first time in this time lapse. But this is what it took to build. It was more than 2 million Landsat scenes, almost a petabyte of data. It was 2 million hours of computation, but because we ran it on because we ran it on 66,000 computers in parallel, we had the result in a couple of days. Whereas on a single computer, it would have taken more than 300 years. So you can understand why it hadn't been done before. Okay, so those are visualizations, but really the heart of why we were motivated to build Earth Engine was to do environmental science at global scale. And so the best, we focused initially on forests. And for example, the Brazilian scientist who first urged us, be careful what you ask us to do, because if it's a good idea, we'll probably do it. And so this Brazilian scientist, Carlos Souza Limazon, is now running Earth Engine operationally monitoring the Brazilian Amazon for more than 2 years. The red is areas of change in the last month. He produces these bulletins, which are then fed right into law enforcement, and he said it has led to very specific, tangible outcomes in the places where they're operating this. Positive reduction. Then we worked with an American scientist, Matt Hansen of the University of Maryland, who first did forest loss and cover in Colorado, and then after we got the kinks worked out, we said, let's go global. So this was published in Science magazine. This is really the first big global result that came out of Earth Engine, and it was the first detailed map of global forest cover and change from the year 2000 to 2012. You could see where there was cover in 2000 and how it changed every year since then. Fantastic interest in this data product. We made it free, downloadable. Thousands of people and institutions downloaded it, and it's now being used to create all kinds of derivative information. But for example, this is another example where it was a huge amount of data because we ran it on 10,000 computers in parallel. We had the result in 4 days. In this case, it would have taken only 15 years if we tried to run it on a single computer. It's one of the comment that Professor Matt Hansen made I thought was really important, which is this is the first map of forests that is globally consistent and locally relevant. Because it is 30 meters per pixel, you can actually use it for activities on the ground. I'm just curious, how many of you even know about this data product? Okay, good, I'm glad. Yeah, the New York Times, it got a lot of attention around the world. So then, but we're still trying to get to impact, right? So we've got now this unparalleled, unprecedented scientific data product, but we wanted to make a difference on the ground. So we worked with World Resources Institute to build Global Forest Watch. So you can go to globalforestwatch.org. That base map is from that data. And you can go in and interact with it and say, well, tell me what has happened in this area. It's continually updating with alerts. And I like this article that, I can't quite read it from here, but Google Earth Engine, Big Data to Environmental Activism. So if a tree falls in the forest now, it doesn't just make a sound, it sends out an alert. Sorry, that was loud. And now the Indonesian government themselves are using this to strengthen their law enforcement. This is also relevant because more than 70% of tropical deforestation is due to the production of commodities. And what's been exciting is that with this kind of data now available, this kind of pressure now, and this kind of empowerment of civil society to know where forest is being lost, companies are making commitments to, in this case, zero deforestation palm oil. So this year, Girl Scout cookies from Nestle will, for the first time, be deforestation free. There's many other applications that are now being built. We have thousands of scientists and institutions, running on Earth Engine. It's all free. This is looking at December a year ago when there was drought. Red means anomalously dry, blue means anomalously wet. You can see the California drought right there. This is what's called an atmospheric river. Remember, we got a very welcome storm in December. This is that storm hitting the coast. We're now working with the European Commission, Joint Research Center, to map global water resources. At that, again, using the Landsat archive and other data to have the first high-resolution global maps of persistent water and seasonal water. And I think this could be useful in California. This will be coming out this year. Here's a fun one. Let's see. Oh, good. So one of our science partners is building a residential irrigation application, right? So we're not only having satellite imagery, we have hourly feeds of rainfall, temperature, all kinds of weather-related data. And so the idea here is that when this is launched, you'll be able to just come in, draw your backyard. We did an experiment because I was going to meet with Al Gore, so we said, how much should you water the rose garden? But anyway, you draw your backyard, and it tells you, okay, this is what you should water, and here's why, and it's based upon predictions and past weather. So that will be fun, I think. Fishing. So more than 20% of the seafood we eat is actually illegally caught. A lot of things are happening out on the high seas that are invisible. These are Chinese trawlers heading out the day that the season opened. It's amazing there's anything left at all. So we worked with Oceana and SkyTruth to build what we call Global Fishing Watch. Everything has to be global. Anyway, it doesn't matter. But as you can see, I don't know if you can see it, but this is illuminating global fishing activity. And the issue is, it's not even just illegal fishing, it's just we're simply overfishing. We can have abundant seas if we fish more intelligently, right? And that's kind of a theme for all of our projects, is that bad decisions are being made because we believe in many cases people just don't have the right information. It's not detailed, it's not timely, it's not in a form they can consume. So we think what we can bring to the table is taking that massive amount of big data, work with the latest, the leading scientists to distill that into information and knowledge, right? Information that matters, that can help drive better decision making. Along those lines, I'm almost done here. I've been asked for years, does Google own a satellite? And I always said, no, I wish we did. Well, now we do. We bought the company Skybox, and the first thing my group did is we said, okay, we need to launch Skybox for Good, where we give free tasking to nonprofit organizations who have a good idea. It's 1 meter per pixel, 4-band data, and it's taskable. And so if you're interested, you can do a search on introducing Skybox for Good. But we've already done some early collects. This was for, I think, Appalachian Voices. And they wanted to show that there's a mine that is expanding without permits. We've had an application process. We selected nearly a dozen really compelling proposals from organizations that want that near real-time satellite data to monitor something that's happening. One example is, again, with the Global Forest Watch project. Landsat data is 30 meters per pixel. So let's say we get a Landsat image that says something's going on here, but it doesn't quite give you enough information. We can send Skybox, Latsi, go find out what's going on. Skybox to take a detailed picture, and then that can be used for further action. All right, where I wanted to end was people sometimes ask me, aren't you terribly depressed by all of this stuff that you're uncovering with these projects? And in fact, this came out today, right? That 2014 was the warmest year on record. This is what it was, turned 100 years ago. This is what it's like this year. What do we do about that? Well, again, I believe that we can change how we live on the planet. And there's a really exciting article I recommend you read that came out in the New York Times around Christmas. Restored global forests, I can't quite read this, but basically can address climate change. Forests are a fantastic sink of carbon, and obviously they produce oxygen that we breathe. And so governments and companies now with these projects, in fact, though that map came from our Global Forest project, Global Forest Change data that we did with Matt Hansen, University of Maryland, are now actively looking to reduce deforestation and to replant forests. So forests can be part of the solution, restored global forests. Again, I can't quite read this, let's see here. But, I mean, the great news, this was a Greenpeace quote, that people should feel hope, right? We're not passive, we're not powerless. There are things we can do to turn around climate change and to live more intelligently and sanely on this planet, which is our only home. Thank you.